Good afternoon, ladies and gentlemen. Today we are solving day 31 of the daily LeetCode challenge for March. And the question we have today is question 2444. Count subarrays with fixed bounds. You are given an integer array nums and two integers min k and max k. A fixed bound subarray of nums is a subarray that satisfies the following conditions. The minimum value in the subarray is equal to min k. The maximum value in the subarray is equal to max k. Return the number of fixed bound subarrays. A subarray is a contiguous part of an array. So, in every subarray problem that we come across, we know there are n squared possible subarrays, which means that in a greedy solution, our worst case scenario would be n squared runtime. And like every sliding or like every subarray question, we can use the sliding window technique to reduce the runtime to just a linear runtime. And the reason why this question is marked as a hard question is because instead of the typical 2 pointers as in sliding window questions, we have to keep track of 3 pointers instead of two pointers. And the 3 pointers that we keep track of is like the question asks. So we have to keep track of, so we have 1 pointer to keep track of the index of the most recently seen min k value, and we have 1 pointer to keep track of the index of the most recently seen max k value. And we just have a pointer to keep track of a possible of the index of a possible value that violates the constraints. And the constraints that we're talking about is the constraints are the value cannot be greater than max k and the value cannot be less than min k. So, a quick recap, we have 1 pointer that keeps track of the min k that we've seen and the pointer that keeps track of the max k that we've seen, and we just have 1 pointer that keeps track of a possible value that cannot be inside of a good subarray. And the reason why we keep these pointers is because it helps us determine the amount of possible subarrays ending in our current index. So I want you to think of it like this. In our answer, or in our subarray that we're looking at, on every iteration, you could think of it like we're looking at a new subarray, and we're going to have to determine if it's good or not. So our ending element is the element we are currently on. So we have to iterate through the array 1 element at a time, and our ending element of our subarray is the element we're currently on, and we have a choice to pick our starting element. So our starting element is the smaller value of min k and max k. So our starting element has to be the minimum minimum index between our min k and our max k, because we want to make our subarray as big as possible, right? So we have a ending element and we want to get the smallest starting element to create the largest possible subarray. So our starting element is just a smaller index of min k and max k, and here comes the curveball, because the index of the index cannot be before the bad element. So our starting element has to be within this range. It has to be within the bad element plus 1 and the minimum of min k and max k. We can't have our subarray start on the bad element itself, so we plus 1 and have it start on the element that comes after the bad element. So in other words, we have min of min k and max k minus bad element choices. These are our possible choices that we can pick our starting element from, because our starting element, or the amount of subarrays that we can construct, is just the difference between the furthest we can go and the bad element. And then we just add the possible subarrays, the possible good subarrays, to our answer. So the runtime of this is just a linear runtime, and the space-time is, the space is 1. We don't use any extra space. So let's start coding. For index n in enumerate nums, if n equals min k, let's initialize our variables. Let's just say v bad, v min, v max. We'll start them all off at -1, and our answer is 0. So if n is equal to min k, then we want to set the vmin to the index. If n is equal to max k, then vmax equals to index. If n is less than min k, or n is greater than max k, then v bad equal to index. So our pointers are set up. So we want to pick our starting element now. So our starting element is just a min of v min and v max, and our possible choices is the difference between that and the bad element. And that basically is how many subarrays we can construct, because we have x possible choices that we determine in this equation. So we have x possible choices that we determine in this equation, and that possible choices just translates to the amount of possible subarrays we can construct. So we can just add x to our answer, and that is basically adding the amount of possible subarrays we can construct at every element that we end on. And we want just to make it the max of 0 because we initialize our variables at -1, so we don't want these to ever be negative. Our answer cannot be subtracted from. We can never subtract from our answer, so we just want to make sure that our answer is either 0 or greater than 0. So that's why we use the max, and then we could just return answer. And just submit. And that is the daily LeetCode challenge for March. I hope you enjoyed the video. I will see you in the next one. Peace out.